Good evening, everyone. I hope I find you well. My name is Teach, and I'm a lecturer. I'm a computer trainer, facilitator in computer networking and cybersecurity. So today I've chosen a very interesting topic that I would want to share with you, my friends. And the topic is going to be covering hubs and switches. I'm going to be covering hubs and switches. It's an extract from a data communication syllabus. And I hope the discussion is going to help those who are planning to certify in maybe Cisco CCNA as well as CompTIA A+, M+, and S+. So I hope my discussion with you is going to help you to sharpen you academically and be able to write and pass those online exams. Okay, so fine, we'll start. So a hub is a device which I can say is a legacy device which has been replaced by a switch. So switches came in to replace hubs, but hubs are the devices that were used long back to come up with computer networks or to plan and implement, set up computer networks. So a hub is a device that we find operating at physical layer, which is our layer number 1. Remember, we've got 7 layers of the OSI model. So the first layer is layer number 1, which is the physical layer. So we find our device hub operating right there. The switch is a device that is operating at the layer number 2, which is the top layer, and the name of that layer is data link layer. So I want you to take note as we continue discussing these topics, that our approach of discussion is based on OASI 7-layer model. Our lessons are going to be framed to the OSI 7-layer model. So we've got 2 layers, by the way, which have been introduced so far, which are physical layer and data link layer. And we have alluded to the fact that a hub is found at physical layer, whereas a switch is at layer number 2, which is the data link layer. Are we together there? So what happens at physical layer? Physical layer is a layer that does not involve any addressing. If a physical layer device receives a message, it simply receives and forward without looking at where the message is going. Receive and forward. No addressing information is referred to. So that is physical layer. Whereas data link layer receives but specifically looks at where the message is going. So the message has got a header file, which is that file at the preamble of the message, which has got an address, and this address is a MAC address. So a switch is going to look at the destination MAC address and find out from its MAC address table how to forward to the destination MAC address. So a switch is more intelligent. It has got to look at the MAC address. A hub is a device that is going to what? To look at, no, it doesn't look at anything. It's blind, by the way. It doesn't look, it doesn't read, it doesn't understand the idea of header files, encapsulated header files. What it simply does is to receive a message, get the message into the shared bus medium. Remember, a hub works based on the bus topology or bus technology, whereby all the ports around the hub or on the hub are going to be sharing a single shared bus path inside the hub. So which means if one device is sending, this is what it means. All the other devices have got to listen and wait from sending and back off from sending until the sending device successfully sends. So only one device is sending it in given time. That is with the hub. If another device attempts to send simultaneously, then we see a case of collision happening. It's a collision situation or case. And a hub would need now the carrier sense multiple access collision detection protocol to clear off the collision and reset the communication process once again. And this takes time, by the way. So a hub suffers from delays. It suffers from delays. It's a slow device suffering from delays, suffers from occurrences of collisions, which were now addressed in the switch. So a switch, what is a switch done there to improve the situation? A switch now is taken out the collision domain from the inside of the switch to the ports. So what does that mean now? If a device is sending, other devices have got not to wait until the sending device finishes. They can send simultaneously. So which means a switch allows multiple devices to send at the same time, which is not the case with the hub. Which means now one device can communicate with another device without worries of a collision, because collisions have been taken out of the internal design of architecture of the switch to the ports. Which means if a collision happens on a switch, it only affects the port the device is connected to. It doesn't affect other devices. Access endpoint devices connected to the RJ45 ports of the switch. That's the switch for you. This is an improvement. Whereas a hub now, a collision, once it happens, it affects the entire density of the ports. Whereas with the switch, it only affects that specific port. And multiple virtual channels or virtual paths can be created inside the switch to allow multiple communication, multiple instances of communications, and in full duplex. In what? Full duplex. What is full duplex, by the way? This is the ability to send and receive. Whereas a hub, it works on half duplex. What is half duplex? Send or receive. You can't do both, send and receive. That is the function of a switch. So the switch is more intelligent than a hub, is more enhanced than a hub. A switch runs on it runs on an operating system, which allows the switch now to be configured. A hub cannot be configured, but a switch can be configured using an operating system. There are different operating systems used. For example, a Cisco uses Cisco iOS. I would want to believe Huawei has got its own operating system. HP has got its own operating system. MikroTik has got its own operating system. These are different vendor names involved in the manufacturing of switches. But myself, I've done Cisco, so I know very much about Cisco. So with this operating system, once an network administrator is logged in, is able to what? To fine-tune, to customize configuration settings, to fine-tune, to optimize the functionality of that device at layer number 2. So which means there is layer number 2 technology which can be configured and fine-tuned. For example, okay, first and foremost, how do you connect to the switch? You can connect to the switch through console connection or through Telnet and SSH. Console is used when it is the first time configuration. But once the switch has been set up, now it can be taken into the network, and any follow-up configuration is now done remotely using the in-band configuration. using configured IP address. Remember, it has got a VLAN number 1, which is the management VLAN, which is now used for remote login as the administrator telnets or SSHs. So what are some of the technologies you configured on a switch? We can see the configuration of VLANs. We can see also the configuration of host name, of passwords. Yes, they are customized according to the needs of the according to the needs and the requirements of the organization. We can see now the configuration of spanning tree, fine tuning of spanning tree. We can see the configuration of trunk ports, of access ports. We can see the configuration and the enhancements in terms of optimization of the MAC address table, all done on a switch. By the way, a switch, when it is done, when it is achieving inter-VLAN routing, oh, by the way, a switch does not achieve inter-VLAN routing, but it passes on information to a layer 3 device, which is going to route now from the source VLAN to the destination VLAN. So which means on a switch you can have a VLAN 2 and a VLAN 3, VLAN 4, VLAN 5, in that order. VLAN number 1 is existing, is pre-existing, it's manufacturer configured. But we can start configuring from VLAN number 2, VLAN number 3, using those discrete numbers. All numbers. VLAN 2, 3, 4, 5, 6, 7, 8, 9, 10, in that order. So to achieve inter-VLAN routing, the information has got to pass through the trunk port, which you would have configured as so, to the layer 3 device, which can be a router or a layer 3 switch, then back to destination VLAN on the local switch. So what is VLAN configuration? This is a technology used to segment at layer number 2. Segment the switch, the bigger broadcast domain, into multiple smaller broadcast domains. That's VLAN. So which means at layer 2 we can achieve VLAN configuration. At layer 2 we can also achieve, like remember we said we've got security overlay, we can also achieve security. How? By ensuring that switch port security is configured. What is that? Known MAC addresses are permitted to be switched by the switch. Unknown MAC addresses are blocked and they result in a violation which can shut down the port. The violating machine or endpoint, end device or host can generate a violation that can shut down the port. So all these switch port security configurations, VLANs configurations, spanning tree configurations, trunk port configurations, access port configurations are done inside the environment of the operating system. So there we are. This is our first lesson. We will continue. I ask you guys to subscribe and support me so that I continue to come back to give you more enriching, more educative topics. Remember, there are so many topics in data communication systems. We have got routing, we have got VLANs themselves, we have got VPNs, we have got firewalls. We still need to discuss this. So I invite you guys to subscribe and support me and allow and help me to grow. This is what I desperately need. I need to grow so that I continue, guys, to engage with you. Thank you very much.